Question 40. In a flock of 12,600 sheep, the ratio of males to females is 1 to 20. The weights of the male sheep are normally distributed with a mean of 76.2 kilograms and a standard deviation of 6.8 kilograms. In the flock, 15 of the male sheep each weigh more than X kilogram. Find the value of X. So for me, I want to convert this total number of sheep into the ratio so I can see like the balance of the sheep for males to females. So the ratio has 21 parts. So I'm going to divide 12,600 by 21. And when I do, it's 600. So that means there's 600 males because that's one part. And so the remainder is going to be 12,000. So this is the males to female ratio. Okay, now if there's 600 males, that means 15 out of 600 is going to be the percentage that 15 is. So that's 2.5% when I put that into my calculator. We'll give you 0.025, times that by 100, and that will give you the percentage. Now, at 2.5%, if you go and look at your normal distribution graph, it's going to say between -2 and 2 is 95%. So the remainder is 5%, and that 5% is going to be distributed equally from the -2 to the start, the leftmost side of the normal distribution graph, and then from the +2 to the end, so the rightmost side of the normal distribution chart. Which means that the z-score at this point is 2. So let's write that here, z-score at this point equals 2. It's +2 because they're asking in the flock, 15 of the male sheep each weigh more than X kilograms, right? So we're looking for the most heavy sheep. So if we use the z-score formula, we can substitute some of these values in. So our z-score equals 2, our X is our unknown weight, and then we're going to subtract the mean, which is 76.2 kilograms, and then we're going to divide that by the standard deviation, which is 6.8, and that gives us 89.8 kilograms. So for part B, it says the weights of the female sheep are also normally distributed but have a smaller mean and a smaller standard deviation than the weights of the male sheep. Explain why it could be expected that 300 of the females from the flock each weigh more than X kilograms, where X is the value found in part A. So, where do they get the 300 from? If we do 300 over 12,000, that's actually 2.5%. So they're saying that at the z-score of 2, our X value is 300. Now, if the mean and normal distribution for the males and the females was exactly the same, then this would make sense. But it's not. The mean and standard deviation of the females is smaller, which means there's going to be less sheep that weigh 89.8 kilograms, like less percentage of sheep that have that weight. So at a 2z score, this X value is going to be lower. So where they're saying if it's going to weigh more than X, well, no, because at that point it's going to be a number less than 89.8. So let's write this down. Firstly, no, because 300 female sheep represents 2.5% of 12,000. If the mean and standard deviation were equal for males and females, this would be true. However, they are not. Since the mean and standard deviation for females are smaller less than 300 females would weigh more than X kilograms. Which is 89.8 kilograms from the previous part.